In this session, I am going to explain abrasive jet machining. The aim of the session to familiarize students with abrasive jet machining. Instructional objectives. This session is designed to understand the working principle of abrasive jet machining, know about applications of abrasive jet machining. Learning outcomes. At the end of this session, you should be able to understand the working principle of abrasive jet machining, clear about merits and demerits of abrasive jet machining. Abrasive jet machining is a non-traditional machining process that utilizes a high-speed jet of abrasive particles mixed with a gas or air to remove material from the workpiece. It is often used for practice cutting, cleaning, and surface preparation of hard and brittle materials. In abrasive jet machining, the abrasive particles act as the cutting tool. These particles are typically made of materials like aluminum oxide, silicon carbide, or diamond. The basic setup of an abrasive jet machining system includes a mixing chamber, a nozzle, and a control system. The mixing chamber is where the abrasive particles are mixed with the gas or air to form a high-velocity abrasive jet. The nozzle directs the jet towards the workpiece, and the control system regulates the pressure and flow rate of the abrasive mixture. The high-speed jet of abrasive particles impacts the workpiece surface, causing erosion and removal of material through micro-cutting and brittle fracture. See the setup of the abrasive jet machining. Now you can able to see that 1 minute. That's the point I want to select. Now you can. This is the gas supply. The cylinder is provided, and this is for on and off. That is, we can valve we can use, and we are providing the filters, and through filtering you can send the purified the gas to the mixing chamber, and here there is a valve and the pressure regulator. We can regulate the pressure, required pressure, and that required pressure gas sent to the mixer chamber. So this is the powder supply and this mixer chamber. So for mixing, we are providing at the bottom of the chamber there is a vibrator, and this vibrating this entire chamber so that the both gas and these abrasive particles are mixing thoroughly, and that mixer the charge will send. Okay, here providing the foot control valve. With the help of the foot you can operate this valve, and through this the nose it will supply to the nozzle, and providing the handle to handle the nozzle with the required orientation on the workpiece. Now you can clearly see that through this nozzle, this high pressure the abrasive jet is coming out and impinging on the workpiece, and due to this high pressure impinging, it's eroded that portion of the material, and the material is removed. So this is the actual workpiece, and through this process, these particles are spread over to the surroundings. So in order to protect this surroundings of the workpiece, we are providing some shield with the help of some hood, and these gases, if you want escape, through this exhaust provision is provided. This is the brief description of the abrasive jet machining. So I have taken this the explanation of this figure from the Skype Labs. Now let us see how it will works. The working principle of this abrasive jet machining involves these following steps. The first one is generation of abrasive jet. An abrasive jet is created by mixing abrasive particles with a carrier gas. The gas and abrasive mixture are passed through a nozzle or a specially designed tool called an abrasive jet nozzle. Acceleration of abrasive particles. The mixture of gas and abrasive particles passes through the nozzle. which narrows down the cross-sectional area. This leads to increase in gas velocity and acceleration of the abrasive particles. The velocity of the abrasive particles can reach several hundred meters per second. That high-speed jet will come and impinge the workpiece. So directing the abrasive jet. The high velocity abrasive jet is directed towards the workpiece surface that needs to be machined. The nozzle is positioned at a specific distance from the workpiece, and the direction and movement of the nozzle determine the machining path. Material removal. When the abrasive particles strike the workpiece surface, they exert a force and cause the removal of material through erosion. The kinetic energy of the abrasive particles is converted into mechanical energy, which results in the removal of small chips or fine particles from the workpiece surface. The erosion process is similar to sandblasting, but with much higher velocities and smaller abrasive particles. Controlling parameters. Various parameters can be controlled to optimize the machining process. These include the type and size of abrasive particles, gas pressure, nozzle diameter, standoff distance between the nozzle and workpiece, traverse rate of the nozzle, and angle of impingement of the abrasive jet. Removal of debris. During the machining process, the removed material and abrasive particles form a mixture called slurry or abrasive laden fluid. This mixture is typically collected and separated from the gas stream using a suction system or a filter. What are the different applications of abrasive jet machining? Let us see that. First one is deburring and edge finishing. Second is micro machining. Third, surface cleaning and preparation. Fourth, cutting and shaping hard materials. Fifth, drilling and hole machining. Sixth, etching and engraving. Seventh, aerospace and automotive industries. Eighth, restoration and conservation. Ninth, electronics manufacturing. 10th, medical and dental application. These are the several applications of abrasive jet machining. What are the merits and demerits? Also, you can see that. What are the merits is it's a non-thermal process, no mechanical forces, ability to machine complex shapes, wide material compatibility, minimal tool wear, surface finish and cleanliness, environmental friendliness, flexibility and adaptability. And the demerits are slow material removal rate, limited material thickness, surface integrity and roughness control, restricted depth control, limited accuracy in certain applications, noise and dust generation, equipment complexity and maintenance, abrasive particle solution and disposal. These are the few demerits of abrasive jet machining. So in this session, I think everyone understand the abrasive jet machining working principle, applications, merits and demerits. Thank you.